Section 2.2, Analyze Conditional Statements. What is a conditional statement? Well, a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. Okay, this is used a lot in science too, conditional statements. Hypothesis and a conclusion. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. So if is the hypothesis, then is the conclusion. Example, if it is raining, then there are clouds in the sky. So your hypothesis is it raining? Okay? And the conclusion is, yes, there are clouds in the sky. Okay, rewrite the conditional statements in if-then form. So the first one is all birds have feathers. We need an if and a then. So I'm going to say if, let's just say if an animal is a bird, then it has feathers. So that's if-then. Two angles are supplementary if they are a linear pair. If two angles are a linear pair, then they are supplementary. Okay, you try these two. I'm going to push pause. You need to try them on your own, put it in your notes, and then push play. There are your first two. Push pause and look over them, and I'm going to move on to the next two. Okay, you try number 3 and 4. Push pause. Okay, the next two. It's going to take some practice, and none of us are going to get the same answers all the time. All right, next, negation. The negation of a statement is the opposite of the original statement. If the original statement is a negative statement, then the negation is positive. I know it's crazy. So negation, the negation of a statement is the opposite of the original statement. And just so you know, if the original statement is already negative, then the negation is the opposite of negative, which is positive. All right, next definition, verifying statements. So conditional statements can be true or false. To show that a conditional statement is true, you must prove that the conclusion is true every time the hypothesis is true. Okay, every time. So for a conditional statement to be true, you must prove the conclusion is true every time the hypothesis is true. To show that a conditional statement is false, you need to give only one counterexample. Okay, only one reason that it's false. Go ahead and write that down. I'm going to go on. Related conditions. I know lots of vocabulary this chapter. To write the converse of a conditional statement, just exchange the hypothesis and the conclusion. Okay, so if you're told to write the converse, you want to exchange the hypothesis and the conclusion. Inverse. To write the inverse, negate both the hypothesis and the conclusion. Okay? Contrapositive. To write the contrapositive, first write the converse and then negate both the hypothesis and conclusion. I don't know about you, but I would get a note card out and write these things down so that I didn't have to memorize them quite yet. Because after some practice, you're going to get used to it. But these are all brand new words to us, and they're sort of confusing. So a note card would be an awesome idea. I've given you an example. Okay, a conditional statement. If the measure of angle A is 99 degrees, then angle A is obtuse. Okay? I know that looks like a less than sign. I couldn't find this in my computer, so I did the best I could. Converse. Okay, if we go back, Converse said to write the converse of a conditional statement, exchange the hypothesis and the conclusion. So converse. I exchanged them. If angle A is obtuse, then the measure of angle A is 99. Okay, that's not true all the time. Okay? It's not. Angle A could be obtuse. It could be anything greater than 90 degrees and less than 180. Oh, I found an error. That should be a little degree sign. Inverse. Okay, inverse said to write the inverse of a conditional statement, negate both the hypothesis and the conclusion. So, if the measure of angle A is not 99 degrees, then angle A is not obtuse. That's also a false statement. Contrapositive says to write the contrapositive, first write the converse and then negate both the hypothesis and the conclusion. So, if angle A is not obtuse, okay, we're going down this way, then the measure of angle A is not 99 degrees. That is also a true statement. So read through those again and hopefully it'll make better sense. But yeah, I would totally write this stuff down in a note card and maybe all the examples too to help you remember. Another way to think about it, again, this is awesome, okay, note card. Conditional, if X, then Y. Converse, flip the X and Y. If Y, then X. Inverse, negate the conditional. If not X, then not Y. Contraposite, negate the converse. If not Y, then not X. Much simpler explanation. Makes total sense to me. Another example. Write if-then form, which is a conditional statement, the converse, the inverse, and the contrapositive of the conditional statement. Guitar players are musicians. Decide whether each statement is true or false. So the first one I'm going to write is the conditional statement. If someone is a guitar player, then they are a musician. And I'm going to say that is true. Okay, the second one is the converse. If someone is a musician, then they are a guitar player. Now, I know some of you listening to this are musicians and you don't play guitar. So this is going to be a false statement. Moving on. Oh, goodness. Okay, the next one was the inverse. So, if someone is not a guitar player, then they are not a musician. I know some of you don't play guitar, but you are musicians, so this is also false. Remember, we just need one counterexample to make it false. And lastly, if you, or if someone is not a musician, then they are not a guitar player. Okay, I'm not a musician. I don't play guitar. Or piano, or etc., etc. But the guitar player is a true statement. Okay, you try this. Same things. Okay, I'm going to push pause and write them out, and you're going to check your answers. I should tell you that this is already the conditional statement. Okay, so we already did the first one. We're going to do the next three. There you go. Push pause and read through the answers, and I think you'll get it. Okay, next set of questions. You try them. All right, let's actually talk through these. So our conditional statement is, if a polygon is equilateral, then the polygon is regular. Okay, it doesn't tell us to tell whether this one is true or false, but I don't think that is true. A polygon needs to be equilateral and equiangular, but it didn't ask us for that one. B, if a polygon is regular, then it is equilateral. That's true. C, if a polygon is not equilateral, then it is not regular. That's also true. D, if a polygon is not regular, then it cannot be equilateral. If it's not regular, it can still be equilateral. It can't be equilateral and equiangular, so that one's false. Okay, that's a break. You can catch the second half. This is the end of part 1. We'll do part 2 tomorrow.